These are a few of my radios, and these are my favorite cookies, oatmeal raisin. Aside from them both being eminently satisfying, at least to me, they have something else in common. Watch this video to find out what that something is.
Hot cookies, anyone?
Hey y'all, Tom, ND3N here. Thanks for dropping by my ham shack for a ham shack chat. Over the last few years, the term supply chain and supply chain crisis has been mentioned a lot. However, outside of a few experts, very few of us understand exactly what the supply chain is and why it might be in crisis. In this video, I'll be giving you an outline of the meaning of supply chain and explaining several different ways that it could be put into crisis. But first, a disclaimer. Nothing in this video should be taken personally or politically. I will present the facts in as neutral a manner as I can. Briefly, the supply chain is the logistics process from raw materials through production into distribution and delivery, and finally disposal at the end of life. Here I have several ham radios and a couple of cookies. All of them use and are affected by the supply chain and its crisis, and in surprisingly similar ways. I purchased these cookies at a local grocery store. I took a look at the ingredients list because anything sold in the grocery store has to have an ingredients list, right? And by my count, there were 27 different ingredients. Now, for those of you who don't know, the ingredients are listed in the order of content. In other words, the first ingredient has the most volume, second is the second most, and so on. The top 3 ingredients in order are wheat, eggs, and milk. As I mentioned, there are 27 unique ingredients that make up the full recipe, and the lack of any of these parts means that you don't have a cookie. Now, to make things simple, I'm not going to talk about all 27 items, and I'm only going to focus on milk. Keep in mind that this same supply chain process will happen for every ingredient with minor variations. In this example, I'll be looking at the supply chain backwards, from the store to the cow. The cookies are delivered to the store from a local distribution center, which took delivery of them from the commercial bakery. That bakery either prepared the full recipe part by part, or they probably used a pre-made mix, which was prepared in another factory. The milk was delivered to this bakery from a milk processing facility that homogenized the milk and took care of some other stuff with it. It produced some 2%, some 1%, some whole milk, some skim milk, some buttermilk, all of that sort of stuff. After they had received the raw milk from the dairy farm or co-op. This is the initial delivery portion of the supply chain for the milk. The step before delivery is the making, which brings us to the factory of milk, which is the cow. A milking cow can produce around 8 gallons of milk per day. But in order to do that, the cow has to be fed and watered, receive regular vet care and vaccinations, and be kept safe, healthy, and protected from the elements. All of these require individual supply chains. To keep all of these supply chains working together requires a plan and a strategy. So planning is part of the whole big deal. Now that you've seen the effort that it takes for milk to become part of a cookie, and that cookie to make its way to the store, let's take a look at the same overall process when it comes to ham radios. This time, we're going to flip our path and we're going to take it from raw materials to the finished radio. It doesn't matter what kind of radio, HF, mobile, or HT, the same process will be required. This time, instead of starting on the shelf and moving backwards, as I mentioned, we're going to start with the mining of rare earth elements. The rare earth elements are a set of 17 metallic elements, and unlike the name implies, rare earth elements are not all that rare and can be found just about anywhere in the world. There's probably a good chance that the soil and dirt in your yard contains rare earth elements. However, they are found in very low concentrations, and they're hard to separate from the other elements. There are two main processes used in their mining. The first involves removing the topsoil and then creating a pond where toxic chemicals are added to leach the separate elements from the removed topsoil. The second method involves drilling holes into the ground and using PVC pipes and rubber hoses to pump toxic chemicals into the earth. This creates another leaching pond, but under the earth instead of on top.
What could possibly go wrong?
To begin with, the chemicals used in these processes can leak into the groundwater and can sometimes affect entire waterways. Both methods produce mountains of toxic waste with a very high risk of environmental and health hazard. For every ton of rare earth minerals produced, the mining process produces 13 kilograms of dust and around 10,000 cubic meters of waste gas, 75 cubic meters of wastewater, and 1 ton of radioactive residue. In short, the process of extracting rare earth elements contaminates the air, the water, and the soil. Overall, for every ton of rare earth produced, 2,000 tons of toxic waste are made. At the recording of this video, the most accurate production of rare earth elements per country in order is China at 168,000 metric tons, the United States at 43,000 metric tons, Myanmar at 26,000 metric tons, Australia at 22,000 metric tons, and a combination of other countries that produce a combined 17,700 metric tons. So why do we put up with all this pollution and all the costs that it takes to take care of this pollution? Well, rare earth elements are used to produce hundreds of products across a wide range of applications, and especially in the high-tech industries. They're used in your cell phones, your computers, electric vehicles, flat-screen televisions, displays, and of course integrated circuits used in your ham radios. There are factories around the world that manufacture integrated circuits, but currently 95% of integrated circuits are manufactured in Taiwan. Now, there have been recent factory fires in Berlin, Germany, in Naka and Tokyo in Japan, which destroyed the equipment used to manufacture these chips. This equipment is not easily replaced. And the CEO of Intel has announced that he expects a shortage of Intel chips to continue through 2024 due to lack of manufacturing equipment. Now, these are all hits to the supply chain for our radios. On the plus side, Samsung and Tesla have announced that they will begin manufacturing chips in Texas, but it will still take several years to design, build, and train workers for these factories. When the supply chain works, it works well. It's a lot of planning, a lot of people who really know their jobs. But when one link fails, the entire chain falls apart. In 1950, as Japan was rebuilding after the Second World War. Deming visited Japan and the Toyota factory there specifically, and recommended that they view production as a system. Now, he sketched out this chart, and with Deming's help, they developed what's now known as the Toyota production system. Now, this led to advances such as total quality management and just-in-time, which are all principles that are used in developing supply chain. Fast forward to the late 1960s, and Ford was having severe quality problems in their factories. They took note of the quality of Toyota cars and trucks and visited a Japanese Toyota factory and asked the managers of that plant how they were able to produce vehicles of such quality. The manager of the plant asked them why they weren't talking to Deming. Now, I put a link in the video description if you'd like to read more about him. Now, I just mentioned just-in-time, which is used by just about every production facility worldwide. This process sets up the delivery of individual component parts on a very strict schedule, often specified in minutes, so that a given part will not be provided to the technician on the production line until just before it will be installed. Now, keep in mind, this means that every individual part has its own supply chain. All these supply chains have to be coordinated. Just-in-time is not only used in the final production, but at just about every sub-tier supplier, from raw materials to different companies making different components. So when multiple links in the chain fail, the entire chain quickly falls apart. It's a large reason why many ham operators are seeing waiting lists for their rigs. I hope that you now understand a few things about the supply chain, how it works, and how bad things can happen when even the most insignificant link in the chain can't or won't do its job. I also hope you can appreciate a good cookie and a better ham radio. Please give me a like.
I like it.
And share this video with your friends.
Share it.
And please comment.
Like, those are the people who just comment to comment.
I know it's hard to do sometimes, but try to keep politics out of the comments. Thank you. Thanks for dropping by for another Ham Shack chat. Until the next Hey Y'all, I'm Tom, ND3N, and I am out.